Imagine a time before telescopes and spaceships, when the night sky was a dazzling mystery. This is the Middle Ages, where towering cathedrals pointed fingers at the heavens, and scholars hunched over ancient scrolls, trying to understand the universe. Back then, most folks believed the Earth was the center of everything. Planets and stars danced around it, like planets on a merry-go-round. This idea, called the geocentric model, came from ancient thinkers like Aristotle and Ptolemy, and it fit nicely with the religious beliefs of the time. It made humans seem pretty important, right in the middle of God's grand creation. But things weren't quite so simple. Scholars started noticing things that didn't quite add up with the geocentric model. Stars and planets didn't always move in perfect circles, and some observations just didn't fit the puzzle. This wasn't just a scientific curiosity, it challenged the whole understanding of our place in the universe. Thinkers like Thomas Aquinas tried to bridge the gap between faith and reason. They believed that God created a perfect universe, but that we could still learn about it through observation and study. This paved the way for a future where science and religion could coexist, even though they might not always agree on everything. Science, though, wasn't quite the powerhouse it is today. Back then, people relied more on ancient texts and philosophical reasoning than experiments and data. This slowed down the pace of discovery, but it didn't stop it entirely. Astronomers like Regiomontanus built clever instruments and recorded their observations, laying the groundwork for future breakthroughs. Slowly but surely, the cracks in the geocentric model started to widen. New ideas emerged, like the sun being at the center, and the universe being much bigger than anyone ever imagined. It was like a new map of the world was being drawn, with the Earth no longer at the center, but just another planet in a vast and mysterious cosmos. Thinkers like Copernicus, armed with precise calculations and celestial observations, dared to unseat Earth from its cosmic throne. His heliocentric model, placing the sun at the center of the solar system, sent shockwaves through the established order. But without tools to validate his theories, it remained a hushed whisper in the celestial wind. Then came Galileo Galilei, his finger pointed not at scripture, but at the heavens. His telescope, a revolutionary lens crafted with improved glass-making techniques, pierced the veil of obscurity. Mountains on the moon, moons orbiting Jupiter, and phases of Venus all contradicted the perfection and immutability of the celestial spheres. These weren't just celestial curiosities, they were cracks in the geocentric foundation, threatening to unleash a torrent of new understanding. But the Church, a powerful protector of tradition, clung to the old paradigm. Galileo's revelations were met with resistance, forcing him to recant his heresies under threat of persecution. Yet the seeds of doubt were sown. His observations, meticulously recorded thanks to the advancements in printing press, echoed across Europe, fueling the flames of scientific inquiry. Like and subscribe the channel. In the next chapter, we will see how the scientific revolution changed the way we understand the universe.